Okay, we're going to start a new unit today. We'll be looking at index laws and rational indices, or in other words, exponents and exponents that are fractions. So index notation, of course, if we have a to the power of n, that just means a times itself n times, or n factors of a. I know this is review, but just so you, so we make sure that you know those exponent rules. If you have the same base, like we do here with a and a, when we're multiplying with the same base, we add our exponents. And the reason that works is, for example, say we have a cubed, which is a times a times a. This is a cubed. And say that's times a squared, which is another a times a. We've got a to the fifth power then. If we count up all our a's, our factors of a, and notice that's 3 plus 2. So that's where that rule comes from. It works the same with division, just opposite. If we've got this, again, the same base, so we've got a base of a, we'll always do the top minus the bottom, the numerator exponent minus the denominator exponent. If we have a power to a power, we just multiply those powers. If we have two factors being multiplied together and both are being taken to the power of n, for example, then we just take each individual factor to the power of n. So we do a to the power of n times b to the power of n. In this one here, we've got division, same idea. We're just going to take a to the power of n over b to the power of n then. Remember, anything at all to the power of 0, whether it's a variable or a number or multiple variables and numbers, anything at all raised to the power of 0 is always going to be 1, as long as a doesn't equal 0. So anything except 0 to the power of 0 is 1. A to the power of negative n is 1 over a to the n. So remember, negative powers do not make anything negative, they just reciprocate, which means if, for example, here we've got this a in the numerator, right? This is a over 1, essentially. So if it's in the numerator, it'll move down to the denominator, like you can see here, and it becomes positive, that power then. And if we have 1 over a to the negative 1, so if it's already in the denominator, it moves to the numerator, and again, the power becomes positive. So a special one that you should really be familiar with is that a to the negative 1 just means 1 over a, as long as, again, a doesn't equal 0. I think that's it for those. Yeah. Okay, so here we're asked to express these in simplest form with prime number bases. Remember, prime numbers are any numbers that can be divided by themselves and 1. So 1 is not a prime number because it doesn't fit for both of those, but 2 is our only even prime number, 3, 5, 7, etc. 11, and on and on. Okay, so right now we've got 9 to the power of 4. We want to write that in a prime number base. So 9 we know is 3 squared, right? 3 is a prime number. So we can write 9 as 3 squared. We've still got this power of 4 outside the brackets. And we're just going to then multiply those powers, because now we've got a power to a power. So we've got 3 to the 2 times 4, or 3 to the 8th power. And in this next one, 2 is a prime number, but 4 is not, so we can write 4 as 2 squared. So we've got 2 squared times 2 to the p, and because they have the same base, a base of 2, we're going to add our exponents because we're multiplying. So 2 to the 2 plus p. And in this third one, again, we're dealing with 9. 9 is not a prime number, but we can write it as 3 squared. So we've got 3 to the x over 3, we've got a power to a power, so we'll multiply those. We've got 2y, and now we've got subtraction of our exponents because we're dividing with the same base. We have a base of 3, and so we'll have 3 to the x minus 2y. Oh, and one more. So here we've got 25. We can write that as 5 squared. Okay, and then again we've got a power to a power, but just be careful to distribute that 2 or else keep it in brackets. So we'll have 5 to the 2 quantity x minus 1, or you can distribute it as 5 to the 2x minus 2. Either way. Okay, so just more practicing with powers of exponents. There we go. So we're going to raise each of these bases to the power of 3. So 2 has to go to the power of 3 and x has to be cubed. So you can leave that. That's totally fine. If you want, you can multiply 2 times itself 3 times, and that'll give you 8x cubed. Same thing here. We have to basically distribute this power of 4 to every single term. So we'll have 3 to the 4, c to the 4 over b to the 4. And again, you can leave 3 to the 4, or you can multiply 3 times itself 4 times, which is 81. Okay, and there's no simplifying we can do here because we don't have the same base. We have a base of c, we have a base of b. There's no way we can simplify it anymore. Okay, remember anything to the power of 0 is always 1, no matter if it's a number, a variable. For example, if you have x to the power of 0, that's going to be 1. It doesn't matter, what it is as long as it's not 0. We have 3 to the negative 2 here. That's going to reciprocate 3. And it'll be 1 over 3 squared. So we're going to, all we do is put our, this was originally in the numerator, so it moves to the denominator and the power becomes positive. And to hold that place value, we put a 1 in the numerator. We can then simplify that further. That's 1 over 9. Okay, here we've got 3 to the power of 0, which is 1. And we've got a minus sign. And 3 to the negative 1, so that's 1 over 3 to the 1. We just take what was in the numerator to our negative exponent, we bring that to the denominator and make our exponent positive. So we've got 1 minus 1/3, which if we make 1 have a common denominator, that's 3 over 3, because we can multiply this by 3, divide by 3, minus 1 over 3, and we've got 2/3. Okay, if you have a fraction to a negative exponent, the easiest thing to do is reciprocate it right away and then make your exponent positive. So for example, we've got 5/3 here. We can reciprocate that to 3/5 and then deal with a positive exponent. So that negative just flips our fraction around. And notice it's always doing that. In this example B, we really have 3 over 1 to the negative 2, right? That's the same as 3. And so what our exponent does is it reciprocates that. It makes it 1 over 3 and then squared. And if we square 1, we've still got 1. So 1 over 9. And we've done the same thing in part D here. So we reciprocated it. We've just got to square both the numerator and the denominator. So you can leave it like that, or you can simplify it further, 9 over 25. Okay, exponents to an nth root. So in this case, we've got x to the power of m, so that power is in our numerator, and the root of n, if you ever have an nth root, a root of any kind, that is going to go in our denominator of our power. So here, for example, we've got a to the 1/2. That means the square root of a. So really, we could put a little 2 here, right? That means square. We just don't write it that way. a to the 1/3 is the cube root of a. So a to the 1/n is the nth root of a. So right, anytime we're dealing with a denominator of our power, so in this case, the 2, it means that root. So we're doing a square root of 49, which we know is plus or minus 7. Here we're doing a cube root of 27, which is 3. So you're thinking, what times itself 3 times is going to give me 27? We know 3 times 3 is 9, times 3 is 27. Okay, so now we're dealing with negatives and roots. So first of all, the negative is going to basically reciprocate what we have here. It's going to make it 1 over 49 to the 1/2. You could leave this 1/2 outside if you wanted, like this. Or you can think, okay, I've got, well, let's finish this. Okay, so we'll take the square root of 1, which is still 1, of course, and then 49 to the 1/2 means the square root of 49, which is 1 over 7. So another way of thinking about C is if we've got 49 to the negative 1/2, that's going to be 1 over 49 to the 1/2, which is the same as 1 over the square root of 49, which is still 1 over 7. Okay, letter D, again, you could do that either way. We've got 1 over 27 to the positive 1/3, and that means 1 over 27, the cube root of that, which is 1 over 3, because 3 times 3 times 3 gives us 27. And in your head, you're thinking, okay, what times itself 3 times is going to give me 27? So this is our answer there. So notice these negative exponents do not make the number itself negative. It doesn't affect whether the solution you're going to get is positive or negative. It just reciprocates what you have. Okay, so some practice. I'll do a couple examples here, and then I'll just pull out the answers and let you finish the rest. So letter A here. We've got 4 to the 3 over 2. So this means 4 cubed and then the square root, or you can do it the other way around. You can do the square root of 4 first and then cube it. So you can write that like this. Oops, that means the cube root. So you can do the square root of 4 first and then cube it, or you can do 4 cubed and then take the square root of it. It really does not matter the order. It's nicer to work with smaller numbers, and we can easily just take the square root of 4. So we know the square root of 4 is 2, and then we'll cube 2, which gives us 8. Letter B. Where can I write this? We've got 8 to the 5 over 3. So again, it doesn't matter. You can take the root first, or you can take 8 to the power of 5 first, but that's a very big number, so it's kind of nicer to do the cube root of 8 and then take it to the power of 5, because we know, again, with the cube root of 8, we're thinking what times itself 3 times will give me 8. We know 2 times 2 times 2 gives us 8. So we get 2 to the power of 5, which is 32. Let's do one of these negative ones. So we've got letter H. We've got 8 to the negative 4 over 3. Again, it does not matter the order. You could do 8 to the power of 4 and then cube root it, or you can do the cube root of 8 to the power of 4, which is nicer because then we're not dealing with such big numbers. So the cube root of 8 is 2. Oops, and there's a negative. My mistake. Okay, let's deal with the negative first. So we've got, this is to the negative 4 over 3. Okay, so to deal with that, let's reciprocate this. We're then going to have 1 over 8 to the 4 over 3, which means which means we can again decide, do we want to take the cube root 4 first or the power of 4 first? I like taking the cube root first. So we've got 1 over the cube root of 8 is 2, and this is to the power of 4. So 1 over 16. Okay, so again, I'll let you please do the rest of those examples just quickly and then check them with these answers. So if you can pause the video and then check your answers. And these are the solutions. Okay, just quickly, negative numbers and powers. So if we have a negative 2 in brackets to the power of 2, that literally means negative 2 times negative 2, which we know is a positive 4. So a negative number in brackets to an even power, and it's very important that it's in brackets, will always be positive. Okay, so it has to be in brackets and it has to be to an even power. A negative number not in brackets, so a negative number with any power is just you're gonna do the power first. So here we'll do 2 squared first, which we know is 4, and then we keep that negative. So we keep this out in front. So no brackets, a negative number to a power without brackets will always just stay negative. Okay, and then if we have a negative number in brackets, but it's to an odd power, it again means negative 2 times negative 2 times negative 2, which gives us a negative 8. So it's always going to be negative. A negative number in brackets to an odd power will always be negative. Okay. So we've got 8 more to do here. This is kind of like rational expressions. We've done a bit of this before. I'm just going to do 2 on each page, and if you could pause the video then and try the rest on your own. So we'll start with this one here. We're just applying all of the exponent laws we've looked at. So we've got powers to a power, so this is going to be x squared, which is then again squared, so that's x to the 4th. We're multiplying those powers. We'll have y to the 6th. We'll multiply 3 times that 2. And then in the bottom, x to the 10 over y to the 4. And then we can subtract because we've got the same bases. So we've got x and x, so we can do x to the negative 6, and again we'll subtract, we've got the same base here, so we'll have y squared. And it says write it with no variables in the denominator, so we've got that, x to the negative 6 y squared. I'll do letter D here as well. I'll do B quickly too, just so you can see. Just remember with these ones to also square that number, that coefficient in front. So we'll have 2 squared x squared cubed, 2 cubed x cubed over 2 to the power of 1, x to the power of 5. We've got the same bases of 2, and we can subtract those exponents because we're dividing, so we'll have 2 squared, and then again we'll subtract our exponents because we've got the same base, so we'll have x to the negative 2. So again, we've got no variables in the denominator, and we're finished. Okay, 2 over 10, these are just numbers. So we can simplify that like any fraction. 2/10 we know simplifies to 1/5. So we'll just simplify those. Here we've got the same base, x and x. So x to the 6 minus a negative. So we've got 6 minus a negative 8, which gives us 14. So because we started in the top, we'll put what we got in the top. So we've got x to the 14. And y to the negative 5 minus 3. Negative 5 minus 3 gives us negative 8. So we'll have y to the negative 8. And that's fine. A variable, remember, is a letter, so we don't have any variables in the denominator here. So that answer is just fine. And if you want to just pause the video real quick, I'll show you the solution to this. Okay, so there's Answer to letter C. Again, I'll just do 2 of these, and then you can pause it for the last 2 and try those. I'll do this first one here, A. So we'll make sure we distribute this exponent of 3 to all of those. So 2 cubed x to the negative 9, because we multiply those. Y to the 12, we multiply those exponents. Again, we want to distribute this negative 5 to each of those. So we have 2 to the negative 5. We'll multiply negative 4 and negative 5 gives us 20, and x to the negative 30. And here we want to express it with no negative exponents. Okay, so and now we can multiply straight across. So in the numerator here, we can combine. We've got 2 cubed times 2 to the negative 5, so we can add our exponents there because we have the same base. So this is 2 to the negative 2. We have x to the negative 9. We have y to the 20. This is over x to the negative 30 and y to the 12. Okay, so again, we have the same base x here. We can subtract our exponents. If we do the top minus the bottom, we'll have negative 9 minus a negative 30. So that's going to give us positive 21. And because we started our subtraction in the top, we'll have x to the 21. So we don't want any negative exponents, remember, so we can move this 2 to the negative 2 into the denominator with a positive power of 2. So we're just taking that negative power, moving it in the denominator, and making the power positive. And with our y's, we have the same base, so again, we can subtract. We'll have 20 minus 12, and we get y to the 8th. And you can rewrite this as x to the 21, y to the 8th over 4, if that makes you happier, but either way is totally fine. What else should I do? I'll do letter D here as well. So we've got our same bases, x to the negative 12, x to the negative 3. If we subtract, we've got negative 12 minus a negative 3. So that gives us x to the negative 9. And we subtract our y exponents. 0 minus 8 gives us y to the 8 still. Or sorry, 8 minus 0. And that's because y to the 0 we know is 1. So it's just going to stay the same. We want to get rid of our negative exponent, so we're going to move x to the negative 9, just that part, just this part here, down to the denominator. So y to the 8, x to the positive 9 then, once we move it down. So if you want to pause it, I'll write the solutions to the other two and you can check. Okay, and those are the last 2 solutions. We've got C and B here.